Assalamualaikum warahmatullahi wabarakatuh. Today our group will present about the assignment application of mathematics that is related to chemistry. So today our topic for the presentation is balancing chemical equation by using matrices.
So I will continue with introduction. Our topic is balancing chemical equation. So we use matrix to as our project to balance the chemical equation. To balance the chemical equation, scientists frequently make educated guesses about the coefficient that will make the equation work. Using matrix to solve a system of linear equations to get the coefficient of a balanced chemical reaction is an alternate way. After the coefficients have been determined, a balanced chemical reaction can be created and utilized to represent how the various coefficients affect the overall reaction. Then, it can lead to a bigger application in the environment. As example, pollution that caused by common chemical reaction.
Next is about theory related. So matrix is a rectangular arrangement of numbers into rows and columns. For example, as we can see, the matrix P has 2 rows and 3 columns. Rows for the horizontal and columns for the vertical. So the dimensions of a matrix can tell its size, the number of rows and columns of the matrix in that order. Since matrix A has 2 rows and 3 columns, so we can write the dimension as 2 times 3, but we pronounce it 2 by 3. So in contrast, matrix B has 3 rows and 2 columns, so it is 3 by 2 matrix. And remember, when working with the matrix dimension, we must remember the rows and columns. Matrix element is simply a matrix array. Each element in a matrix is identified by naming the row and column in which it appears. For example, the element G21 is the entry in the second row and the first column. So in this case, G21, the matrix element is 18. So in general, the element in a row I and column J of matrix A is denoted as Aij.
Okay, the theory related to the our project is determinant of a 2 by 2 matrix, which is you can see the formula on the screen. For 2 by 2 matrix, we need to multiply A and D and then minus by C multiply B. And then for determinant of a 3 by 3 matrix, to calculate the determinant of 3 by 3 matrix, you can choose any row or column and then multiply each entry by its corresponding cofactor, which is cofactor is you need to put the sign of plus, minus that follow the cofactor, and then you can add the 3 products. This gives you a determinant. So overall, you can say that the formula is like that, which is beside the hashtag emoji. So inverse matrix. To find the inverse matrix, first you need to work out the minor and then put in the signs, the minus signs to form the cofactors, and then transpose the matrix by rewriting the first row as the first column, the middle row as the middle column, and the third row as the third column. So and then you divide by the determinant, and the important is you need to remember that n by n matrix has an inverse if and only if the determinant is not zero. So it is good idea to calculate the determinant first. So you can save your time to find either it has an inverse matrix or no, and then you just check whether the rest of the procedure is necessary.
next is about linear system. So in this case, it actually is very easy to solve. For example, we have two simultaneous equations. So from this simultaneous equation, we can turn into matrix equation. Now we take the matrix equation and multiply by A inverse. For example, let A equal to 2, 1, 5, 3, and then we invert it into A inverse of 2 by 2 matrix, and then we do the multiplication. We take the matrix equation and multiply by A inverse. So the final answer we can get is x equal to 2 and y equal to 1. So we can work out the inverse of the matrix of coefficient, so we can solve the simultaneous equation.
So now I will proceed with mathematics related to chemistry project. The statement is the amount of carbon in moles and the amount of water in moles produced is always the same. This is because the balance equation shows that the glucose to carbon dioxide ratio is 1 to 6, which is the same as the glucose to water ratio is. The chemical reaction we get from the statement is C8H18 plus O2 producing O2 plus H2O. A, B, C, D is the coefficient that we need to find. So first we have equation implies that C is 8A plus 0B equal to 1C plus 0D. For H, we have 18A plus 0B equal to 0C plus 2B. And for O, we have 0A plus 2B equal to 2C plus 1D. Then we rearrange the equation to the green and purple equation. Next, we can get matrix A from A, B, C and matrix B from the D equation. The next step is to find determinant A. Determinant A we can find from equation that has been explained by Nisa just now, and we get negative 36 for the determinant.
To get value of A, B, C, we need to multiply inverse matrix, matrix B and determinant A. Matrix B and determinant A already shown in the previous slides. So we have to find the inverse matrix. To find inverse matrix, it has 4 steps that had shown in the related theory just now. So to find inverse function, first of all, find the minor, like shown in the slide. This is how to find minor. So the final answer is minor A that shown in the slides. Put all the answer in the matrix, like in the minor A. Then find the cofactor by changing the sign according to their arrangement or times with the positive and negative sign. After that, transpose the matrix by changing row to column or vice versa. Lastly, find the inverse function by using the formula 1 over determinant A times the adjacent A. So we can get the inverse function, A inverse matrix. So this is the final result this is the final result. As I said just now, to find a coefficient, it has to multiply the inverse matrix times matrix B times determinant A. So we can get the coefficient as shown in the slide. So we can get the negative for C8H18 minus 50 O2 produce negative 32 CO2 minus 36 H2O. We can simplify the equation into 2 C8H18 plus 25 O2 produce 16 CO2 plus 18 H2O.
Okay, so in the conclusion, from this project, mathematics in chemistry project, that has been explained by our presenters and from the slide itself. Firstly, by using matrices, we can balance the chemical reaction. Balancing the chemical reaction specifies these two identities of a chemical reaction and aids in understanding how to prevent or increase the process. And the second one is matrices help us to identify the quantity of the reactant that needed in the reaction. And matrices also useful and powerful in the mathematical analysis or in the collecting data. The matrices also one of the ways that has been useful to understand the relationship between the reaction is by balancing the chemical equation. The primary method of assuming coefficient that could balance the equation and the testing reliability is constantly and not always accurate. However, matrices can be used to quickly and accurately provide the coefficient per individual species for a balanced chemical reaction. That's all from our group.